Hi, welcome to Armchair Philosophy. I'm Rubin, and today we'll be talking about the basics of logic. Logic is the foundation of philosophy, but it only really formally appeared when Aristotle published his writings. Aristotelian logic focused heavily on the use of syllogisms, which you may or may not be familiar with. If you're unfamiliar with the term, an example of a syllogism is, if A, then B, if B, then C, therefore if A, then C. However, even using syllogistic logic can be a bit arcane. And so the fundamental task that we have to do is break down sentences into their logical counterparts so that they can actually be used in those formulas. Once a statement is translated into its proper logical form, it can be substituted with a letter. For example, going back to the syllogism that we just covered, A, in that example, if A, then B, could be representative of the statement, Harry is at home. However, in cases such as the statement, Harry and Sally are at home, we have to make a few changes. One of those signifiers, A or B, can only be representative of one statement, because sometimes individual parts of statements may be true or false, and they have to be accounted for while making your argument. For example, if Harry is at home, but Sally isn't actually at home, she's at work, we would translate it as A, Harry is at home, and not B, Sally is at home. It is not the case that Sally is at home. To make it a little more complex, we can separate the subjects Harry and Sally and represent them as, say, H and S, which are usually in a capital case. Then we can take the quality, being at home, and represent that with a lowercase letter, so a lowercase h. So capital H, then lowercase h, would be Harry is at home. And then capital S and lowercase h would be Sally is at home. In some sentences, this can become increasingly complex. For example, if we take the sentence, Jim can only visit Sam if both Harry and Sally are at home, we need to make a few adjustments. We have another factor, which is Jim, and he's committing an action, which is visiting Sam. We can further use parentheses in order to kind of mathematically break down our sentence. In this case, capital J representing Jim, and a lowercase v representing the action of visiting Sam. When that's put into its full context, Jim visiting Sam, if and only if both Harry and Sally are at home, it's represented in something that would look like this. When we start introducing parentheses and making longer logical statements, we have to distinguish between the minor operators in the sentence and the major operator. In practice, this refers to the symbol which is outside of most of the parentheses. For example, in J, if and only if, opening parentheses, H and S, closing parentheses, the if and only if operator would be the major operator, and the truth value of the statement would be contingent on the truth value of that operator. If we use a different sentence, like Harry is not at home and Sally is not at home, we can represent it as tilde, opening parentheses, H plus or dot, S, closing parentheses. And in this case, the tilde, which is representing the statement it is not the case, would be the major operator. In cases where the major operator of a logical statement is always true, you have what's called a tautology. And in cases where it's false, you have what's called a contradiction. We call it the major operator because it's the most important operator that's used in the logical statement. In logic, the way that we demonstrate the truth value of an argument or a statement is by writing out the full argument step by step. In logic classes, you'll probably be given a long list of problems to work with, but they all essentially boil down to going from given premises to a given conclusion. We bridge that gap by introducing rules of inference and rules of replacement as they pertain to the operators which are currently in place. The goal is always to cut down on the amount of steps that are required, so that you avoid any kind of complications and keep your argument as concise as possible. When we do this in writing, we reference which rule we're using in relation to which lines, and we come to our conclusions based off of that. All of these rules are freely available online, but a few examples of them include modus ponens, abbreviated as MP. Step 1. If P, then Q. Step 2. P. Step 3. Therefore Q. Disjunctive syllogism, abbreviated as DS. Step 1. P or Q. Step 2. Not P. Step 3. Therefore Q. An example of a rule of replacement would be a biconditional exchange, abbreviated as BE. P, if and only if Q, can also be translated as if P then Q and if Q then P. Essentially, you can break down the whole thing kind of like doing math. When and where the rules apply, apply them. And when you have a full argument, you can then analyze its truth value by means of producing a truth table. When you make a truth table, what you're essentially doing is seeing if each piece, for example, H or S, are true, and then looking at the conditions which exist within the argument and seeing how it pans out and whether or not it creates a true outcome. For example, look at the following argument. 1. P. 2. Not Q. 3. X, if and only if P and Q. 4. Therefore X. We can't actually get to the conclusion X using that argument. We've established that both P and Q must be true in order for X to come about. But we've also established that it's not the case that Q is true. In other words, that the truth value of Q is false. Obviously, this video can't cover every topic in logic. That would be ridiculous. But hopefully I've pointed you in the right direction so far. Before I go, I want to introduce the concept of indirect proofs, also called the reductio ad absurdum argument. It has 3 basic steps. First, you introduce an additional premise, which you're ultimately trying to prove to be false. This is called an assumption for an indirect proof. You assume that for the sake of the second step, which is to derive a contradiction which has appeared on previous lines of your argument. Once the contradiction is derived, you can do the third step, which is to establish that the opposite of what you assumed for the indirect proof is true, since it would be absurd for that thing to be false. Here's an example of an indirect proof. You have 3 premises. 1. P or Q. 2. If P, then R and not R. And 3. If Q, then S. Do you see the contradiction in line 2? That's where we begin to use an indirect proof. Let's switch around the Q and P from line 1 and make the statement step 4, Q or P. Then in step 5, we assume not Q for the sake of an indirect proof. In the 6th step, we're continuing with our pursuit of that indirect proof by establishing P. Lines 4 and 5 provide a disjunctive syllogism which we can use to do that. Then, by means of modus ponens in step 7, we establish R and not R from lines 2 and 6. Which leaves us the conclusion of Q by means of an indirect proof as line 8. We established that not Q is absurd, and that the logical conclusion is Q. We then know that S, because if Q, then S. If you familiarize yourself with the rules of inference and replacement, then this video should have given you the fundamental tools necessary to at least start engaging in logic. You should be able to create simple proofs and apply the reductio ad absurdum argument when you need to. Logic can benefit us in many ways, from understanding rhetoric to understanding computer languages. It also helps you understand when someone's spouting absolute BS, and makes it really easy for you to call out that BS. And more importantly, it helps you explain why it's BS. A lot of philosophy is just that. And that's all this time for Armchair Philosophy. I'll see you next episode. Don't forget to comment, like, and subscribe. And if you feel so inclined, donate to our Patreon, which will be in a link in the description.